The cost of 3D printing services can vary greatly, ranging from below $1 to $100 or even higher. But why are there such differences? Let's start by exploring the key factors affecting 3D printing costs. The type of 3D printing technology being used plays a significant role in pricing. Technologies like fused deposition modeling, FDM, stereolithography, SLA, and selective laser sintering, SLS, exhibit differing degrees of intricacy and machine-associated expenses. When comparing 3D printing technologies, two notable ones are fused deposition modeling, FDM, and stereolithography, SLA. FDM is cost-effective, using thermoplastic filaments for part building. SLA offers high accuracy and versatility, but comes at a higher cost. Other options, like SLS, SLM, and DMLS, are pricier due to their rarity and ability to work with metals. Except for considering the initial cost of the 3D printer, it's essential to pay attention to aspects such as the setup price, operation prices, and ongoing maintenance costs associated with the 3D printer. The setup price covers the initial installation and calibration of the printer. The operation price accounts for energy consumption and labor cost during the printing process. The maintenance price includes routine cleaning, repairs, and replacements of components. Its cost depends on the complexity of the printer and the specific parts involved. Second, materials. Materials used in making strong 3D printing keep increasing as 3D printing keeps progressing. Plastic 3D printing materials come in various forms, including plastic filaments, resins, and polymer powders. These materials are popular for their versatility and affordability. Filaments are used in FDM printers. They come in a range of plastics like PLA, ABS, and PETG, each with different properties. Resins are used in SLA printers. They offer more intricate detailing and can be engineered for specific characteristics like flexibility or high-temperature resistance. Polymer powders, used in SLS printers, enable the creation of durable and complex parts. On the other hand, metal 3D printing materials are more costly due to the complexity of working with metals. They include titanium, stainless steel, aluminum, tool steel, and nickel alloys. These materials often require precise temperature control and specialized equipment. They're used in technologies like direct metal laser sintering, DMLS, and binder jetting to create strong and functional metal parts. Third, the size and complexity of the 3D model being printed. Larger prints consume more material and might require longer printing times. Complex designs might need more additional support structures or post-processing time, which can add to the final cost. For instance, a small and straightforward 3D print, like a basic geometric shape, will likely cost less due to its simplicity. However, a larger and more intricate design with delicate details or overhangs may require additional support structures. This can impact the printing time and the need for post-processing to remove those supports. Fourth, part size. The size of the part directly influences both the required material quantity and the choice of printing technology. Larger part sizes will necessitate a greater amount of materials and lead to extended printing durations. The overall cost will be affected. Fifth, order quantities. If you're printing a batch of parts simultaneously, the cost per part can be lower than printing them individually. This is especially advantageous for smaller items. For example, imagine you're 3D printing a set of customized keychains. If you print 10 keychains at once, the overall material and setup costs get distributed among all 10 pieces. This reduces the cost per keychain. Finally, post-processing can increase the overall cost. It may include processes like sanding, painting, or assembling multiple parts. These are essential for achieving a smooth surface and functional final product. When considering post-processing, think about a complex architectural model. Once the 3D print is complete, you might need to smooth out surfaces, add intricate details, and paint them to resemble the final building. These steps contribute to the cost. Now, let's do some math to better grasp these concepts. For instance, consider the cost of producing a basic prototype weighing 200 grams. Assuming the PLA filament costs $25 per kilogram, the calculation is as follows. 200 grams, 0.25 gram, $5. However, if you need a high-detail prototype of a medical device made from a specialized resin, the cost could be closer to $50 due to the material and increased printing time. Crafting a personalized phone case through 3D printing is a popular practice. The cost of printing a phone case can vary significantly, spanning from approximately $1 to $50, considering factors like material choice and post-processing requirements. Let's say the phone case, which weighs 35 grams. Then the cost calculation would be 35 grams into $0.025 per gram means $0.86.